In this video, we are using the trapezium rule with 6 ordinates to estimate to 3 significant figures the area under the sine x graph between 0 and pi over 2. So the sine x graph, as we hopefully know, looks like this. We just find an approximate value for the area between 0 and pi over 2 on the x-axis. We could find the exact area using integration, but if the question says use the trapezium rule, then you have to use the trapezium rule. So here's a very rough sketch of that section. I'm going to divide it into 5 strips because the number of strips is always one less than the number of ordinates. So 6 ordinates means we have 5 strips. This distance here from 0 to pi over 2 has a length of pi over 2 minus 0, which is just pi over 2, and we are dividing it up into 5 strips, so each little strip will have a width of pi over 10, and that is our value of h in the formula for the trapezium rule. So really I've just done that formula here at the end, b minus a over n, but if you're going to use that formula without thinking, then make sure you remember what n represents. N is the number of strips. Here I just thought it through instead of looking at the formula. Starting at 0 with a width of pi over 10 means my ordinates are going to, for the x values, are going to be 0, pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, and 5 pi over 10. Of course, 2 pi over 10 I could have written as pi over 5, 4 pi over 10 I could have written as 2 pi over 5, and so on. Now on the calculator, I'm not actually going to use the table mode here, because unfortunately, actually make sure calculate is in radians, because there's trigonometry here, and although we're not actually doing any integration, it would need to be in radians anyway to get the right answer, so radians. As I was saying, using the table mode, unfortunately you can't store the y values that come out of it, or if you can, then I currently don't know how. So going from 0 to pi over 2 with a step of pi over 10 gives me these, and if I highlight these y values and try to store that one under a, for example, it just won't let me. If it worked, it would have given you a confirmation message saying that that number has been stored under a. So unfortunately, I'm not going to use the table mode for this one. I'm going to go back to ordinary mode number 1. Well, let's figure out these y values. Well, a couple of them we shouldn't really need the calculator for. The first one, when x is 0, sine of 0 we should know is 0. So y is 0 there. And the one at the end as well, pi over 2. If you do A-level maths, you really should know that sine of pi over 2 is 1. So the first and last, nice and easy. The others are going to give us big long decimals, and I've already worked them out here, so you don't need to watch me enter them into the calculator one by one. But I'm going to store them under A, B, C, and D. For subbing them into the trapezium rule formula, that means I'm not using any rounded values. So here we go. I'm going to do sine of pi over 10, and I'm going to store that as A. A little confirmation message there, number has gone to A. If you're ever unsure, use the recall function. So shift and then recall. And at the moment, I've got 0.309 stored under A. So yeah, that has worked. I'm now going to go through B, C, and D, replacing the numbers that are currently stored under B, C, and D. So I'm going to use the up arrow to go back to this, and then just turn that into 2 pi over 10. Store under B. Again, I'm going to go up, change that 2 into a 3, press equals, store under C, up, change the 3 into a 4, store under D. Let's check that has worked using recall. So A 0.309, B 0.587, C 0.809, D 0.951. I haven't stored 0 and 1 because I don't see the point. So now to the formula. So this area will be approximately, The formula says half times h to begin with. I worked out h is pi over 10 earlier. And then we have brackets that open and don't close until the very end. y0 plus yn is first, so that's our first y value plus our last y value. And then it's plus 2 lots of all the other y values added together. Now because I've labelled them A, B, C and D, I'm now going to write A plus B plus C plus D. And I've told the examiner what my values of A, B, C and D are, so I'm okay using this notation. Right, let's enter that in. So half of pi over 10 is pi over 20, open brackets. 0 plus 1 is 1, plus 2 lots of, open another bracket, and then alpha A plus alpha B plus alpha C plus alpha D. It might not matter on the calculator, but we do have 2 brackets to close, so I'm going to make sure we do. And I press equals. So get 0.99176 answer to 3 sig fig. So 0.992 to 3 sig fig. Now that is only an approximation. We can see from the curvature of the sine graph that our trapezia will lie underneath that curve. So it makes sense that this is an underestimate. We can now get the true value either by doing actual calculus. So the integral of sine x is negative cos x, and then subbing in 0 and pi over 2. So put the top limit in, you get minus 1. Sorry, you don't, you get 0. Put the top limit in, you get 0. And then take away and sub the bottom limit in, I get minus 1. So I'm taking away minus 1. So the true value, I believe, is 1. That fits with 0.992 being a slight underestimate. You can also use the calculator. Make sure you're in radians. The integral of sine x, make sure you close the brackets, between 0 and pi over 2, which is 1. That concludes this example.